right, so yesterday in class we started chapter 2, which is all about linear equations in two variables. Section 2.1 is just kind of a general introduction to these types of equations. So before we were working with just one number line, right? Now we're going to be working with two. We've got our x-axis, which is our horizontal number line, and our y-axis, that's our vertical number line. The origin of the number line, when we just had one, was 0. It's the same as before, but now it's 0, 0, and I'm going to explain what that means in the next slide. It's broken up into 4 quadrants. In quadrant 1, both our x values and y values are positive. In quadrant 2, our x values are negative and our y values are positive. In quadrant 3, x and y are both negative. And in quadrant 4, x is positive and y is negative. It's important to note that any points that are on our x-axis or our y-axis don't belong to any quadrant. This is called the Cartesian plane. It's also called the coordinate system, the xy plane, the rectangular coordinate system. It goes by many different names. So when we're working with the coordinate system, we can define the location of any point on our coordinate system using an ordered pair. An ordered pair is a pair of numbers enclosed in parentheses and separated by commas. So by a comma. So for example, such as the point when x is 2, y is negative 1. So here I have where x is 2, y is negative 1. You guys had switched from blue, right? So that's the point positive 2, negative 1. It's called an ordered pair because it has a specific order to it. The first coordinate is always our x coordinate, and the second coordinate is always our y. And it's important that we remember it's alphabetical. X comes before y in the alphabet, so its coordinate should come first. So let's take a look at the following ordered pairs. I've got A over here. Okay? A is when x is negative 6, right? Y is 5. So this would be the ordered pair, negative 6, 5. B is when x is 1, y is 3. So we'd have y, comma 3. C is when x is 6, our y value here is 0, right? That's our origin. And D is when x is negative 1, y is negative 5. So if a point is located on an axis, one of its coordinates is always going to be 0. For example, every point on the x-axis has a y coordinate of 0, and every point on the y-axis has an x coordinate of 0. When I have a linear equation in two variables, can be written in standard form where I've got ax plus by equals c, where a, b, c are any real number, and a and b are both not 0, right? I have to have at least one x or one y. We call this a linear equation in two variables, and the graph of a linear equation is going to be a straight line. And every point that straight line passes through, right, on our coordinate plane, every point it passes through, these points are going to be the solutions. They're going to be points that satisfy this equality. So first thing we can do is we can fill in the table for an equation below by substituting in given x and y values. So let's go ahead and fill out this table. So if I have x equals negative 1, that means I have 2 times negative 1 plus 3y equals 6. I'm substituting into our given equation in standard form. That means I have negative 2 plus 3y equals 6. I add 2 to both sides. I get 3y equals 8. I divide by 3. I get y equals 8/3. Next, I have when x is 0. If x equals 0, I have 2 times 0 plus 3 times y equals 6. 3y equals 6, so y equals 2. And then I can also plug in a y value. If I have y equals 5, I have 2 times x plus 3 times 5 equals 6. that means 2x plus 15 equals 6. I subtract 15 from both sides. 2x equals negative 9, so I get x equals negative 9 halves. So now I've filled in our table, okay? I want us to think for a moment about a point on the coordinate plane. If I have a point on the coordinate plane, just one point, how many lines can I draw through that point? You might say 4, but that's really not the case, right? I can keep going. All these lines are different. I can draw infinitely many lines through one point. But what if I have 2 points? How many straight lines can I draw through 2 points? The answer is only 1. So one way to figure out how to plot a linear equation in 2 variable is to find 2 points on the line and draw the line between them. So, for example, here, in order to plot the line 2x plus 3y equals 6, I could plot when x is negative 1, y is 8/3, and when x is 0, y is 2. So why don't we go ahead and do that? I know when x is negative 1, y is 8/3, and when x is 0, y is 2. So let's go ahead and plot these 2 points on a coordinate plane. It's not the best coordinate plane, but it'll do its job. So I have when x is negative 1, which would be right here. Y is 8/3. 8/3 is almost 3, like it's 2 2/3. That'd be like right here. So we're going to plot our point. This is the point when x is negative 1, y is 8/3. Then we have to plot our point when x is 0, y is 2. So here's where y is 2. This is where x is 0. And then I can draw my equation, my line, through those 2 points. Now, if I had graphed this perfectly, because this is 2x plus 3y equals 6, right? This is our linear equation. If I graph this perfectly, every single one of the points on this line would satisfy this equation, right? That means it would make it a true statement. So let's say this point right here is when x is 3, y is 0. And let's see if that point satisfies our equation. So I've got 2 times our 3 plus 3 times 0 equals 6. 6 equals 6, that's true, right? So this point is also on our line and it's also a solution. So we can find additional solutions by graphing. 2 really important points that we can use to graph are our x and y-intercept. Our x-intercept is when our line crosses the x-axis, and our y-intercept is when our line crosses the y-axis. So our x-intercept is always going to have a y-coordinate of 0, and our y-intercept is always going to have an x-coordinate of 0. So to solve for the x and y-intercept, you let y equal 0, and to solve for the y-intercept, we let x equal 0. So I have 4x minus y equals 3. To find the x-intercept, I always like to write this down. I let y equal 0, and to find the y-intercept, I let x equal 0. So now I have 4x minus 0, because I'm substituting in for y, equals 3. 4x equals 3, so x equals 3/4. Now, x equals 3/4, this is not my x-intercept. My x-intercept must be written as an ordered pair. This is just the x-coordinate of my ordered pair. So I have that my x-intercept, which you can short to x-int, is when x is 3/4, y is 0. Now let's go ahead and find our y-intercept. So I have 4 times 0, because we're plugging in 0 for x, minus y equals 3. That gives me negative y equals 3. I divide both sides by -1. I have y equals 3. So my y-intercept, again, it has to be written as an ordered pair, is when x is 0, y is 3. So there we found our x and y intercepts of 4x minus y equals 3. Now I have negative x plus y equals 6. Let's go ahead and find the y-intercepts, the x and y-intercepts of negative x plus y equals 6. Switch to blue. In order to find my x-intercept, I let y equal 0. In order to find my y-intercept, I let x equal 0. Negative x plus 0 equals 6. Again, I'm substituting in for y. So I have negative x equals 6. That's going to give me x equals negative 6. So my x-intercept is the ordered pair. When x is negative 6, y is 0. Now for my y-intercept, I let x equal 0. So I have negative 0 plus y equals 6. So I have y equals 6 is my y-intercept. So I write my y-intercept as an ordered pair. When x is 0, y is 6. So there I found the x and y-intercepts of negative x plus y, that's a y, equals 6. These last two I want to analyze together. I've got x equals 4 and y equals negative 6. Now this is kind of different, right? Because I'm working now in the coordinate plane, right? I've got an x-axis and a y-axis, but these two equations only have a single variable. So let's take a look at what's happening here. So I've got x equals 4 and y equals negative 6. I want to find the x-intercept, so let y equal 0, and the y-intercept, I'm going to let x equal 0. Same thing over here. But let's see what happens. Okay, so let's go ahead and find the x-intercept. I let y equal 0. Well, how many y does this have? You could kind of think of it as having no y or 0 y. So my x-intercept is just going to be when x equals 4. There's my ordered pair. Now to find the y-intercept, I let x equal 0, but I can't do that, right? Because 0 doesn't equal 4, right? That's an untruth. So why do we think this doesn't have a y-intercept? Well, let's go ahead and graph a beautiful coordinate plane. Oh, okay, I tried. All right, let's think about x equals 4. Every point on this line has to be where x equals 4, right? It doesn't matter what our y value is. When x is, we'll graph this in green. When x is 4, y is 0, right? But if y was 1, wouldn't x also be 4? Or if y was negative 6, right? So every point on the coordinate plane where x equals 4 is going to be part of our solution set. So here is our graph of x equals 4. It's a vertical line, right? Is it ever going to cross this y-axis here? No. We call those parallel lines, and we're going to talk about those later on. But that's important for us to know right now, is that this does not have an x and a y-intercept. I bet you, being smart like you are already thinking, oh, now I kind of think I know what's going on with y equals negative 6, right? It's not going to have an x-intercept because I can't let y equal 0. It's going to have a y-intercept because this is like 0x plus y equals negative 6. So y is negative 6. So there I have my y-intercept. Let's go ahead and graph this in orange, right? This is where y equals negative 6. So the solution set to this equation is going to be every point on our coordinate system where y equals negative 6, right? All those points are solutions. It's going to be the line that goes through y equals negative 6. It is parallel to our x-axis, right? It's never going to cross our x-axis. So it doesn't have an x-intercept. So friendly reminder that when you just have one variable, this is something we need to get down. X equals 4, its graph is always going to be a vertical line. And y equals -6 or y equals any constant is always going to be a horizontal line.